objectives for part B are to compare the conductivity of ionic and covalent compounds as solids, liquids, and dissolved in solvents. Materials are evaporating dishes, conductivity apparatus, spoon, burner, and all the materials listed in the chart.
Goggles, do not forget.
Hi. The procedure is to test each of the substances or mixtures listed in the table. To test the conductivity, lower the electrodes into the material in the beaker. Rate the conductivity according to the number shown on the conductivity apparatus and place the number in the chart. Here's the chart.
Yeah!
We assume that ionic substances can conduct a current in their molten state. So therefore, we must create a molten state.
Therefore,
i.e.
we are hitting the substance which is called,
sodium thiosulfate.
and when it is heated, it turns into molten, and then that's when we check the conductivity.
And then we can compare conductivity in its non-molten state to its molten state.
But the non-molten state doesn't have conductivity.
Right!
Right!
So tell us whether this is ionic or...
Covalent.
Very good.
Good question.
Well, I just ate a tuna sandwich and I'm assuming it's digesting in my stomach at the moment, so another 15-20 minutes it should be in the lower intestine in a form called chyme. That's what I'm doing right now.
Okay.
Or I'm going to plug this in. Yeah, I'm plugging this in, you notice? Watch the technique.
It's like this. Plug in.
See, that would be wrong, so you do it this way.
Like the face.
Right, face to face. Then of course I go over here and I do that, and then I use my super huge muscles to pull down this door.
Oh, look at his arms. Look at his arms. They're so
Yeah, they're
super
bulging?
strong. Oh.
Ugh, okay.
So now if it explodes, it won't do it in our face? Is that the
Now
point?
we're going to look at melting this.
Oh. When it melts, we stop it?
Just gonna stand there and watch me burn. Well, that's alright.
Hello, we're going to now transfer over to Daniel Brudno.
We're going to check the conductivity of the molten element.
Compound.
Compound. Okay, press this and put it in. Oh, correct. 10.
No way!
Wash that off. Let's turn it off. Unplug it, please. Unplug.
The conductivity is 10. Unlike when it was in its solid state and it was 0.
Yeah. It's been a ride.
Hey guys, I'm back. Paul, stop touching me. Thank you. Okay, so in part B, we used a different method to identify if a substance is covalent or ionic, and that method was by taking a substance and putting it in a crucible, and putting it on a hot plate so it reaches its molten state. And when it does reach its molten state, we put a conductivity meter in it, and we check the conductivity. So, because we know that covalent substances do not conduct electricity, we can conclude that if there is a conductivity, then the substance is not covalent, therefore ionic. and like alcohol is covalent because it doesn't conduct electricity really well. We also know that ionic substances have an ability to conduct electricity well on their molten state. So let's say salt, we know that it comes apart in ions, making an electrolyte solution, which electricity can jump across really well. And also just adding to both parts, that we didn't even do this method, is just the obvious method is to take two elements and look at them on the periodic table. And if we see that they're from different sides of the table, then we know that the electronegativity difference is going to be much higher than 1.67 for sure, which means it's ionic. We also saw that most ionic substances are bonding with metals, and most of the covalent substances are carbon-based products like sugar, and that's why they have nothing to do with each other's side of the table, the metal side. And this experiment, and it just gave us the ability to identify easily. We can just look at a substance and identify easily if it's covalent or ionic. And that's it. Thank you. Bye.